Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today I will show you a short tutorial on how you wanted to design a ladder diagram inside CX Programmer and how you wanted to integrate your design inside the CX Designer. Right, so first and foremost what you should do is you should click at the new file and then you can choose your device type. So for today, I will choose CP1H as my device type. And then you can click OK. So after you click OK, you will have like a field that you can write out or design your ladder diagram in it. Right. So first, what we wanted to design is we wanted to design like a open switch. Okay, so we click at open switch here. Okay, and we click at the field inside the CX programmer. Right, so first things that you need to initialize is you need to initialize the address of your switch. Right, so this time to initialize the address inside CX programmer, you can initialize it as 1.00. Okay, and then what is the name of your switch? Okay, for example, my switch name is S1. Okay, so you have S1 here. And then you must have an output. So here we have a coil, or you can call it a lamp because it will be light up later on. Okay, you connect it here. And you need to assign an address to the coil. So this time you assign an address as 100.0. Okay, so the name for your switch, for example, is Y0. Right, so you get it like this. But if you didn't get the Y0 exactly like this, you can connect it by yourself by using these connections, okay, the horizontal connections. Alright, so next circuit that we have is we have one closed switch. Okay, we give the address of 2.00. okay, we name it as S2. Okay, and then we have another light, okay, or another coil, and we give a name of 101.00. okay, we call it Y1. Right, so if you have a connections that is not interconnected with other circuit, you need to put it inside the new tab here. So you can see here, this is step 0, this is step 1, and this is step 2. So after you finish design in one tab, another tab will be automatically appeared. Okay, so right now we already finished our simple design of CX inside CX programmer, and we wanted to simulate. So to simulate, you can just click at the simulations and you click at the work online simulator. Okay, you wait for a little bit. And then you can see here is that because this is a closed switch, it will be automatically connected to the coil or the light, and the light will be switched on. Right, so it will be light up. But here, because the switch itself is in open state, all right, so your lamp will not be turning on. So what you should do is you click at the switch and then you right click and then you go to the force and you click on. So it will be force switch 1 to turn on, and the lamp will be turned on also. Alright, so for switch 2, if you wanted to close the switch, you can still right click, go to force and switch on. Right, so because it is initially in close, when you switch it on, it will be open. So for S1, it is actually initially open. So when you switch it on, it will be closed. Right, so that is how you wanted to create a simple circuit inside CX Programmer. Right, so now we stop the simulation. And what if we have a circuit that is interconnected? For example, this kind of circuit, let me show you. Okay, let me delete it first. Right, so next we wanted to create a little circuit called self-holding circuit. Okay, right, So for self-holding circuit, we have a switch here. We give the address of 12.00, and we name it as S2. Okay, and then we have a coil here, and then we initialize one switch here. It is in the same tab, okay, because we want it to interconnect each other, and we need to give the address of 100.00, which is the same address as the light here. Okay, and then press enter. You see here, if you are doing the CX programmer, if you see the red line here, okay, it means that your circuit is not correct, so it is in error. Okay, so this has an error because this switch or this connection is not connected to the end of the circuit. So this is the end of the circuit, so you need to make sure that your circuit must be connected to here. Alright, so for this type of self-holding circuit, we need a vertical connection here. Okay, so you can see that when we connect the vertical here, the vertical line, so there are no red line here, so it means that your circuit is correct. Right, so you can go to the Work Online Simulator again to simulate your circuit. Right, and you can force on. So right now the light is turning on, okay, and then you can switch off the switch one. Okay, still the light is turning on, so it is called self-holding because it can hold the switch on state by itself. Okay, right, so to switch it off, we need to force off switch S2. Force on switch S2. Okay, so the switch Y0 here, it works when this Y0 is light up, this switch will be on. Okay, so it means that it will be closed lah after Y0 is turning on. Okay, alright, so because it has the same address, so it is being interconnected to each other. Alright, so next I will show you like a simple example of timer. Okay, so inside CX programmer, we can also design a timer. Okay, alright, so let's remove some of the circuit. Okay, remove it all. Okay, so right now we wanted to design a timer. Okay, so as usual, we get the normally open switch. Okay, we give the address of 1.00 and switch S1, and then to get or to design the timer, you need to use this one. This is the new PLC instruction. Okay, you click here. So to design the timer, basically you have to name it as TIM space, and then the number of your timer. For example, this is timer number 1001, and then you space, you need to have hashtag here, and then the countdown value. Okay, for example, I wanted to have 50 countdown, and then you press OK. Alright, so next is the name of your timer. So timer, you put the name of timer 1 or any other name lah that you wanted to put. Okay, so this is the timer that you wanted to design. Alright, so next what you have to do is you have to make another circuit. Okay, so if you want to design a switch which will be turning on after the timer has been finished, what you have to do is you should put the address of T1. It address with the timer 1. So timer 1 you put T1. If timer number 2 you put T2. If timer number 3 you put T3 here. And then you put OK, and it will automatically address it as timer 1. Okay, timer 1, and then you put the lamp here or the coil here. You name it as 0.00, which is the address, and then it is Y0. Right, so what you should do is you should start the simulation. You click at the Work Online Simulator. Okay. Alright. So right now we wanted to switch on switch S1 in order for us to start the timer. Okay, as usual, you right click, you force on. Okay, you see here the countdown has begun, and after the countdown has been finished, this switch will be turning on. Okay, this switch has been turning on and your lamp is turning on. Alright, so this is how you can use CX Programmer to design a simple ladder diagram circuit, or you can also use it as a timer circuit. Alright, so the next tutorial will show you how you wanted to design a CX designer, which is like a SCADA capabilities that shows a GUI for you to design or for you to incorporate this kind of ladder diagram inside your system. Alright, so to do this, you need to open up your CX designer. Okay, so when you open up your CX designer, you can see this interface, and then you can click at the new file. Alright, so they have the model here. You don't have to change it, the system version, but you need to put your project title. For example, I put it sample 1. Okay, you can also rename your file name or your locations. Alright, so for this tutorial, I'm not changing anything. I'm just put it into the project title, and then I click OK, and then I click OK. So in CX designer, you have a multiple page. Okay, so you can rename your page. Okay, as you can modify the title here. For example, I put it as page 1. Okay, I click OK, and then you will see this interface. Right, so this interface is like things that will be displayed inside your dashboard later on, your SCADA dashboard. Right, so because this software will be automatically connected to the CX designer, so we must make sure that our CX designer has been designed correctly. Okay, so for these things, I think that I wanted to use another example. Okay, which is the earlier example that we have done. Right, okay, let me delete it first. Switch S1 is open, and we have output here. We put it 100.00, which is Y0. Okay, alright, and then we delete this one. We delete the output here. Okay, and then we delete the switch here. We put switch 2.00, the address, and then S2, and then you put another coil here, which is 200.00. So the address is depend on you, what is the value that you wanted to put, but you need to make sure that you put the correct number, because you wanted to link it up after this. Okay, so right now you have a switch 1, okay, with the address of 1.00. You have switch 2 with the address of 2.00, and you have the coil or the lamp with the address of 100.00, and you have another coil or another light that has the address of 200.00. Right, so let's go back to the CX designer. So in CX designer, we have some parts, okay, some accessories or some widgets or some button that we can use. All right, but this tutorial only shows like a basic one. All right, so you have on-off button, word button, command button, bit lamp, word lamp, multifunction, and so on. Right, so you can exploit by yourself later on. All right, so first is we wanted to use the on-off button. Okay, for on-off button, we can do the size here, because previously in our CX programmer we have two buttons, right? So the first button and the second button. Okay, and then you need to move it. Okay, right, so next we have a lamp. So we are choosing the bit lamp here. Okay, lamp, the first lamp and the second lamp. Right, so what you should do here is that you just should, what do you call, verify or indicate the correct address for each lamp or each button, so that it will be linked perfectly. Alright, so for the first button, you can modify it here, serial ALA. So the address is 1.00, right? So you modify here, it become 1.00. Okay, and the second one is when we go back to our CX programmer, the second switch is 2.00. So you modify it as 2.00. Okay, and the first lamp, the address is, we go back, the first address is 100, the first lamp. So you can modify it as 100.00, and then for the second lamp, the address is 200.00. So you can just modify it here. You click at the correct light or correct button, you modify it here. And then you can click Save All. Okay. And then you go back to the CX programmer. You go to the simulation. Alright, so previously you are clicking the Work Online Simulator. But this time you will click at the Start PLC PT Integrated Simulation. Okay, you click OK. And then it will start simulating. So, alright, so right now you are seeing that your CX programmer is being simulated because of the green line here. And then this is the GUI that is being appeared inside your screen. Okay, so this is switch 1, this is switch 2, this is lamp 0, and this is lamp 1. So according to the circuit, if we press this button, this light will be switched on. Okay, because this is push button, so you need to push in order for the lamp to switch on. And if you release, it will be released. Okay, you click and it will be switched on. Right, next is the next button, the second button. You need to play it continuously so that the lamp is being turned on. And if you release the click, it will be switched off. Okay, because it is only push button. It is not like a switch that you wanted to make it fixed. Okay. Right, so if you want your lamp to become to be switched on continuously, you need to use the self-holding circuit that I've been showing to you earlier. Right, so this is basically a basic tutorial, a very basic tutorial for CX designer and CX programmer. Okay, so I hope that you will be able to start your project, okay, in a PLC by using CX designer and CX programmer. Okay, so I think that's all for today's lesson. Thank you for your cooperation and good luck for your program and for your project in the future. Thank you.